9-2b, adding and subtracting rational expressions. Right, so we introduced the concept of common denominators in the last lesson. So in the problems we are about to see, we will not be given a common denominator right off the bat. We will have to find it ourselves, right? And in order to find that common denominator, we will look at the denominators of each piece, figure out what the least common denominator is of all of those, and then we're going to multiply by a version of 1 within each of the terms to get a common denominator. Okay, so consider here, what should we multiply by to get common denominators? 4 over y minus 5 over 7. Right now, we cannot subtract these as is. We need a common denominator. What will that common denominator be? Well, look at the denominators of each. Y, 7. Okay, 7y is going to be our common denominator. So in order to get that common denominator of 7y, we need to multiply each fraction by something. Okay, we need 5/7. Instead of it being 5/7, we need it to be something over 7y, but we need it to still be equivalent to 5/7. So in order to make that happen, we need to multiply 5/7 by a version of 1. Okay, and the version of 1 we need to multiply by is y over y, right? And I got that because I know that I already have a 7 here, and the denominator just needs a y to be multiplied in there in order to be able to have that denominator of 7y, okay? Whatever we multiply on the bottom, we have to do on the top because we need this to be a version of 1 to preserve that equivalence, okay? And then y, what do we need to multiply y by in order to get this LCD? 7, okay? So we'll multiply this first fraction by 7 over 7. And then this is going to allow us to combine them, okay? 7 over 7 times 4 over y. We're going to multiply straight across. We'll get 28 over 7y. And erase this, give myself a little more space. Okay, that minus sign is going to stay there for now. Now multiply 5 over 7 times y over y. 5 times y gives us 5y. 7 times y gives us 7y. And look at that. Now we have common denominators. We can go ahead and combine these into a single fraction. Okay, now ask yourself, can this be simplified further? Can this be factored? 28, 5y cannot be factored further. This is our fully simplified solution, okay? All right, so what should we multiply this middle one? What should we multiply by here in order to get a common denominator? Well, first we need to know what is the common denominator. 3x, 5x, both have an x already. 3 and 5, what is their least common multiple? It's 15, okay? Now asking ourselves, what fraction are we going to multiply each term by? 4x plus 1 over 5x needs to be multiplied by a version of 1 in order to have a denominator of 15x. 5x minus 3 over 3x needs to be multiplied by a version of 1 in order to produce a fraction that has a denominator of 15x. Okay, so look at your denominator. Right now it's 3x. We need it to become 15x. How can we make that happen? We can multiply it by 5. Okay, so we're going to multiply this first rational expression by 5 over 5, and then here we have a denominator of 5x. What can we multiply 5x by to get 15x? 3. So we'll multiply by 3 over 3. And the key here is that our quantities would be protected. Okay, so say that we were to work out this problem, it would look like this. 5 times the quantity 5x minus 3 over 15x minus, again, I'll just erase this, give myself a little more space, minus 3 times the quantity 4x plus 1 divided by 15x. And then now we can combine these into a single fraction. Okay, if you're confused about what to do now, my suggestion for you is to use your brain, obviously, but look at your numerator and ask yourself, can the numerator be simplified further? We want to simplify the numerator as much as possible so that we can see if it's going to be factorable and if anything can cancel out. So let's distribute this 5. Let's also distribute our 3. 25x minus 15 minus 12x minus 3. And again, we're still over 15x. I recognize you may not have room for this. You don't need to necessarily write this down, but right now we're thinking about what do we need to multiply by to get there, and I'm just working this out so that you can see it, okay? Combine your like terms on top to get 13x minus 18 all over 15x, okay? 13 is prime, cannot be broken down further. So because 13 is prime, it means that 13 and 18 do not have a greatest common factor other than 1, so we are done. Okay? Right now consider something like this. Okay? Right now we cannot add them. Cannot add these two together because they don't have a common denominator. One denominator is x minus 3, one is x minus 8. So ask yourself, what is the least common denominator? Well, you just got to multiply those two together, okay? So what do we need to multiply this denominator by in order to get our least common denominator? X minus 8. Okay, so our version of 1 here is x minus 8. And then here, it's x plus 3. Okay, I'm not going to work this one out any further because I recognize you don't have enough space, and we will get enough practice in our upcoming examples. All right, let's consider this one. Okay, we have a whole lot of stuff going on. In general, we want to make sure, I'd suggest that you guys write these steps down in some space that you have in your notes, okay? But generally with these, we want to make sure we're fully factored. So factor fully if it's not. Then we want to find the LCD. Then we want to ask ourselves, what do we need to multiply each fraction by? So multiply by what is needed to get LCD. Okay, and then 4 we're going to simplify. So, are we fully factored? Let's see. Can we factor anything any further? No, we cannot, okay? I know that because 3ku squared, there's no addition, there's no subtraction, there's nothing that can be simplified, okay? 4y squared, there's no addition, no subtraction in this numerator, so we can't be factored any further. So now let's find the LCD. Okay, 10 and 5 have a least common multiple of 10. A squared is here, a is here, so we want a with the highest exponent. Here we have a b, and then there's no b in the other denominator, so we still need that b represented. And then there's no k in this left denominator, but there is in the right one, so we got to include it with the exponent there, okay? I wrote this in a poor spot, didn't I? Let me write that again down here. LCD is 10a squared bk to the third. Okay, and then now we're going to ask ourselves, what do we need to multiply each fraction by in order to get that common denominator? Okay, so 10a squared b, we already have a 10. We already have an a squared, we already have a b, so we just need to multiply this fraction by k to the third over itself. Our other fraction, 5a k to the third, in order to get from 5 to 10, we need to multiply by 2. In order to get from a to a squared, we need to multiply by a. In order to get from no b to having a b, we need to multiply by a b. K to the third is already here, so we do not need to multiply by k at all. So 2ab over itself is what we need to multiply by for this one. Okay. Now let's perform that multiplication. 3ku squared times k to the third becomes 3k to the fourth u squared. And that's over our common denominator. And then 4y squared times 2ab becomes 8aby squared. And I'm writing my letters in alphabetical order. That's a common thing that mathematicians do. Okay, and we're over our common denominator. Now we are going to simplify. Okay, so because these have the common denominator, we can write it over single fraction bar. Okay, 3k to the fourth u squared plus 8ab squared all over our common denominator, 10a squared bk to the third. Can we combine our numerator at all? Can we factor anything out of our numerator? No, we can't, so we are done. Okay, let's try this one. Step 1, are we fully factored? Yes, we are. We are fully factored. Now we're going to find our least common denominator. Look at each of your denominators and you'll see that the LCD is x times x plus 2. Now we're going to multiply by what's needed. Okay, x plus 2 is already here, so we just need an x. X is already here, so we just need an x plus 2. Now we're going to multiply. Okay, this left numerator becomes x times x plus 3. And I'm going to go ahead and write these over a single fraction bar in this step. Okay, x times x minus 3 minus, now we have our quantity. Remember, this quantity becomes something that's in parentheses, minus the quantity x minus 4 times the quantity x plus 2. So we are over a single fraction at this point in time. Now we're going to simplify as much as possible. Okay, simplify your numerator as much as possible. Simplify numerator as much as possible. That's just to see if anything cancels out. So distribute this x. Okay, and then we are going to use FOIL here. And we're going to put that minus sign there. We're going to keep this in parentheses. So x squared plus 2x minus 4x minus 8. And that's all over our common denominator. I'm going to go ahead and distribute that. But I know I can get back into fully factored form with that denominator very quickly if needed. And then we're going to combine like terms. So x squared, remember that this negative is going to get distributed. Okay, so x squared minus x squared, we don't have an x squared anymore. 3x minus negative 2x becomes 5x. And then negative 8, this will become 5x plus 8. And then we're over x squared plus 2x. And this is your final answer. The 5 and 5x plus 8 cannot be factored any further, cannot be simplified, so we are done. Okay. I will go through the final 4 examples in your notes in the next video. I'm going to pause this right here, so I'll catch you in another second.